Hello and welcome to video number 18. Today we are going to talk about naive Bayes classifier. We are going to split or see this in two sections basically. We are going to calculate probabilities manually, and then we are going to use the Gaussian classifier in order to do the same, and then we are going to check the difference. So I have my code ready here to run it. So let's get started and explain it step by step. So for this, we are going to use pandas as always, NumPy. And from the scikit-learn library, we are going to use the Gaussian function and the accuracy score function. So for this, we are going to use the Titanic data. You can download this from cadal.com. And basically, this data set says whether a person survived or not. And we have a lot of features for each person, like sex, age, sirens or spouse aboard, parent children abroad, and things like that. So let's start with the processing. Let's check the shape of the dataset. So we have 13 columns and 1,300 rows. We are going to create a data frame with only two rows, two columns, sex and survive. So we have male, female, and survive is a 1 if yes or 0 if they did not survive. Then we are going to put in another column, or we are going to change the column to be ones or zeros, whether the sex is male or female. So as you can see, female is 0, male is 1. And then we are going to drop the nulls. Let's check the new data set and we have 1309. So apparently there was only one null. Now what we need to do is to split the data set into train and test data sets. First we are going to put in the features the sex and survive columns and in the label the survive. Then we are going to split the features and the label into two data frames, let's say. For training and testing purposes, 20% will be testing, 80% will be training. We already saw that in the previous videos. Let's check the shape of the X train and Y train data frames. We have 1000 rows, and for the test we should have around 200. Okay, now next let's calculate the probabilities manually. So first we need to check the extreme value counts, and we have 644 survive, did not survive, and 403 survive. So the probability seems to be 38% of the people survive. Let's check in the other data set for the wide, I mean the training data set, the testing data set, and that's 37%. So as you can see, the numbers are very close to each other. But what about if we do the same but based on the sex, on gender? So let's do the same. Oh, okay, I think we have an error here. Yes, let's execute this first. So we are putting the males in one data frame and the females in another data frame. Okay, now let's check the probabilities of surviving if for the gender male or female. So for the male, we got 20% of survival probability. But for the female, we have 70%. Why is that? Because the votes are always for women and children first. So that's why we have higher probability for women than for men. Okay, but we did this manually. At this time, we didn't use any classifier, and that's what we are going to do next. For this, we are going to use the Gaussian naive-Bayes model when sex is known. So we split the information we have into train and test as we did before. Then we are going to build the model, and for that we use the Gaussian NB function. And then we are going to fit the model. So we pass the training information, the X data frame and the Y data frame, and then we run the prediction function. The prediction function will give a number that we need to test. So let's check the accuracy score. That's another function from the same library. And we have that the accuracy for this machine learning model is 76%. Now let's split the people who actually survived and predicted survival into a new column in the data frames. Let's check. Okay, we have actual survived, predicted survived. As you can see, some are correct and some are wrong. Let's do the same for male and female. And now we want to know the accuracy score for the data frame with men and the data frame with women. And here we have for men 79% and for women 70%. This accuracy is really great for this model. As you can see, using a naive-Bayes classifier is a lot better than doing it ourselves. And we have better prediction and better accuracy score. I hope you find this video informative. Remember, this is video number 18, and see you in the next one.